Hey folks, I thought we'd take just a moment here to review some of the terms that we've gone over to make sure that we've all got them down pat. So when you've got a line segment AB and there's a line right in the middle, equidistant from both endpoints, we call that a what? Often we label it M because it's a midpoint. Now there's another M word, and that is when we connect a vertex to the midpoint, the vertex of a triangle, to the midpoint of the side that is opposite to it. Right, so opposite of A is BC, here's the midpoint, and so we'll call this a median. But there's two other kind of lines we've been drawing in triangles. One is the right bisector, and the right bisector is just a line that passes perpendicularly through a midpoint. So this is a right bisector. And then finally, most recently, you would have learned about altitudes. And an altitude also hits a line at a 90-degree angle, but it's not going through a midpoint. It's extending through a vertex. So from a vertex through the side that is opposite it at a 90-degree angle. So this is an altitude. Now, you may have triangles where something is both a median and a right bisector, or maybe even all three. So for instance, give you an example of that. So let's take like an equilateral triangle like this. So if I were to draw this line right here, you'd see that that is definitely a median, right? It's passing from vertex through to the midpoint the other side. It's also a right bisector because it is bisecting this line here. And it's also an altitude because it's going from a vertex through to the opposite side at a 90-degree angle. So this is a right bisector, a median, and an altitude. It's all three, which is pretty cool. One more little kind of exception that I don't know any of our videos would have covered, but I want to take a look at with you. And that is if we're drawing altitudes on triangles like this. So if an altitude extends from a vertex, so let me just label these X, Y, Z. What would the altitude from vertex X be? Well, it needs to intersect the opposite side at a 90-degree angle. Well, there's no line that I can draw from here inside the triangle that's actually going to do that. So what I'm actually going to do here is it doesn't actually have to intersect the opposite side, but it has to intersect the line that runs through the opposite side. So it would be right here. This is the altitude. So the altitude is actually outside of the triangle itself. And you see that's actually going to be true for the altitude from Y as well. See, Y is going to have to extend outside the triangle as well. Now if we were to draw the altitude from Z, it would be much more like the ones we've been doing, right? That runs right through the triangle itself. But you may come across questions where it asks you to find an altitude, and that altitude is actually somewhere outside the triangle. So kind of weird to think about, but there it is. Hope that helps, guys.